Hey guys, Andy here at MVP Java. Thanks for joining me. Today we're going to be taking a look at JUnit 5, an introduction. Right now, Milestone 1 has come out as of July 2016, and so I think it's worth to take a sneak peek on what's going on. We're going to take a look at a high-level overview of the architecture. We'll take a look at how to run JUnit 5 tests, even though there's no native ID support available. We'll take a look how to do that and mix JUnit 4 and JUnit 5 tests, as well as concentrate on JUnit 5 examples. So let's get through that right away. So what's the problem with JUnit 4? Well, JUnit 4, the way it is it's been around for about 10 years now, right? Or if not a little bit over 10 years. And so requirements have changed over time. We have complex requirements now, more involved environments like continuous integration environments and such. So we have a lot of different types of developers working on this single jar. Even though it's got multiple packages in there, it's becoming a maintenance nightmare now, okay? So if we take a look, us developers, we're writing tests. We've got the engine developers using that jar, and we've got the IDE and build tool developers here also accessing the same jar. So what has happened over the years in order to get things done is the tool providers have been accessing a lot of the private internals using reflection, and it's become such a habit that the engine developers know that they don't have the freedom to change those internal privates as they would like. So that's becoming a maintenance nightmare. Also, all these tool developers have to repeat a lot of the same code, which is to say they have to discover the tests, they have to execute the tests, they have to report back the results. All these kind of boilerplate activities have to be repeated all the time, okay? So that's become a problem. And also, how we extend the framework through runners, right, in JUnit 4, and then through rules is also problematic. You know, runners are very heavyweight, especially if you want to implement something easy. And rules are kind of simplistic in the sense where they're really just wrappers like an AOP, you know, kind of like an at, you know, a round device where you have before and after happening before and in a lifecycle fashion. So it's not really able to address the complex requirements of some extensions. So in this case here, JUnit 4 has served us really well, but it's time to move on to this architecture and to something else. So here we go with JUnit 5. So it's not just one jar anymore. It's a collection of jars to address specific types of functionality now, so different groups can work on different jars. So much more modular. It's a complete rewrite, and it's a rewrite that's using Java 8. Okay, so we're going to see how lambdas comes into the pictures. So here we've got us, developers, writing tests. We're using the interfaces and the annotations defined in this org.junit.jupyter API. So here's the Maven artifact that's going to be needed in your pom.xml file. All of them are going to have the Maven artifacts mentioned, right? So we're going to be using the @test for JUnit 5, which is great. They didn't change that in terms of the name. There's some new annotations there we're going to use, and there's a base set of assertions in there as well. They decided not to get too involved in there since Hamcrest and AssertJ really have the market share value of the assertion frameworks there, which is good. So we also need the engine though, so that's the Jupyter engine. And we need that because it's going to be implementing those interfaces in our API, as well as processing our annotations. But it's also going to be discovering and executing the tests that we write as developers. So this is why we have this arrow here going both ways from the API to the engine. And I'm showcasing here the Jupyter test engine, which is really what is going to get registered once it's on the class path. So now all these engine developers, for example, the Jupyter engine developer, which is what we're going to be using, like I said, the Jupyter test engine. And if you're a custom test engine developer, can now use this API to actually implement an engine. So API for all engine developers to implement. So this is great because now there's a lot of, you know, that boilerplate code, a lot of it's been written for them, right? So how would you like to discover and execute tests? It's up to you. JUnit 4 has decided to go about this in a hierarchical test fashion using node abstraction, which is fine. That's what we're going to be using. But if you envision something else, well, here's the API you have to implement, right? And you have to implement this interface called test engine, which basically has three methods. I think it's get ID, execute, and discover. And that's exactly what Jupyter test engine does directly and indirectly through this hierarchical abstract class. Okay. Now, in order to pick up these test engines, they have to be discovered, and that's exactly what the launcher does over here. So the launcher goes off, discovers these on the default class path using Java Service Loader, and all it does is in the jar file it looks for this package. In the meta-inf/services, there has to be a fully qualified name of a class that implements the test engine interface. Bingo, we have the Jupyter test engine that gets picked up. It'll actually also pick up in this example that I've written the vintage test engine, which is responsible for executing JUnit 3 and JUnit 4 tests, so we can mix them together. Okay. Now, unfortunately, because the native IDE support is not available for us yet, we're going to have to bootstrap this using a runner. Okay, so runners from JUnit 4, and there's a JUnit platform.class there that in its constructor is going to call the launcher factory in this launcher, and it'll loop through after discovering all these engines and orchestrate discovering, executing the test, and bringing back the results to us. Okay, so for now we're going to have to use that runner. Later on, you won't need to use that anymore. So let's take a look now at our examples. Okay, so as a first example, I'm going to show you guys how to mix these, right? So there's our runner that I just explained, okay? This guy needs no introduction. That's our JUnit 4 test. What really is we're here for is this 5, right? So JUnit 5 test, you'll notice the import statement. I put it all there so we don't have to scroll up there for this one. And again, I'm using the Jupyter as the assertion. So there's a couple of big things here in this very small example that I've changed. One, the at test in the JUnit 5 does not have any attributes, so there's no timeout, there's no expected. Expected is handled by assertions built in now, and there's no timeout, okay? The other thing is visibility. Notice there's no public here, whereas there's public in JUnit 4. So you can have any access modifier now in a JUnit 5 test, but you cannot have private. So that's fine with me, okay? The other thing that is in your face is that the message, the error message, right, will only come at the end. So before, it was in JUnit 4, it was at the beginning, right? So this makes more logical sense because variable arguments should come at the end of the argument list, okay? And also, if we take a look at some of these base assertions, right, you won't see anything crazy popping up in your face here. They're kind of all basic ones. One of them is assert all. We're going to take a look at that. That's a new one. But as you scroll down, you'll notice you're seeing these suppliers of strings, okay? So suppliers of strings means that we can use lambdas. So we can defer the execution or the evaluation of our string, especially if they're expensive strings to build. And you can also have suppliers, Boolean suppliers, in the condition, okay? So if we keep on scrolling down here, I'll eventually hit one. There you go. So you got some Boolean suppliers here. And if we keep on going down again, you'll just notice some of just the negation of the asserts. You'll notice that we have some assertThrows, right? So we'll be able to replace the expected attribute in the at test that we had in JUnit 4 now through an assertion. And this one takes in executable as an argument, which means that it'll wrap up the whatever we pass in as a lambda in an execute method, and it'll wrap that in a try catch to make sure that the assertion is not the assertion but the exception is caught. Okay, so pretty lean set of assertions. If you need more, go get Hamcrest, or in my case I would rather assert J. Okay, so let's run this, test this file. And okay, so let me open up also this guy here. So you'll notice that we've got the green bar for each. That's good. And in the output, which is more interesting in this case here, you'll notice they discovered 2 engines with the IDs JUnit Jupyter and JUnit Vintage. And that's because, like I said, they both have the meta-in/services/ and the fully qualified name of the class that implements that interface. Now, to test 0 failures, I'm happy with that. Okay, so let's go on to our next test, which is an electrical outlet test. Take a look here. All my imports have to do with Jupyter, right? Except for the runner that I'm using to do this. Now you'll notice I commented out the selector called select packages. It basically has the name of the package in which houses all the tests. So if you go take a look at the tests here, I got 3. Now I don't want to run them all in one shot when I say run tests, so just for demonstration's sake, that's why. But so I commented it out, but I wanted to show you it anyhow, okay? So over here, the idea is that we have an electrical outlet, and in the constructor of the electrical outlet, we pass in a provider, okay, which can have any implementation. So that's what we're testing. One big thing that you'll notice right off the bat is that the Lifecycle annotations have changed names. So it's no longer before class or after class, they're before all and after all. And instead of at before, we have at before each, and at after, we have at after each. So very small learning curve there, okay? The reason why they did this was because now there's an abstraction of tests, right? We're not just dealing with classes. So it could be anything. You can be testing files, whatever. So they came up with this naming abstraction. The other thing is that before all and after all have to be static, okay? So for now, I just put some printouts in terms of printout lengths for most of them. But for the before each, which is before every test, again, it's the same thing in JUnit 5. A new instance is created for each at test that you've defined. I'm creating a mock for an electrical provider, and I'm passing that electrical provider to an electrical outlet. So for every test, that'll be built, okay? So here's my first test. Now, if you take a look at the camel case of the test name, it could get pretty long to read. So we have this nice display name annotation now that allows us to have a more readable feel to our tests, okay? So you can put that there, it'll get outputted inside the output of the test results, okay? And you could also put spaces, special characters in there, whatever you see fit. Then I have here my mock setting up my expectation to return an electricity object, and I have my base set of assertions, right? I just put a couple there, but we kind of went down the list. So what's different here is you'll notice that in my optional message here, if things go bad, I have a lambda expression to represent a supplier of type string. So you'll notice I'm pretending here that this is some big expensive string to build. Obviously you'd be calling some getters and getting the string from somewhere else for some object, okay, to justify this kind of example. Or you can use a regular string. They're all overloaded anyhow. Or you can use, again, a lambda to represent this string anyhow. So whatever, you choose whichever way you feel better with or addresses your use case better. All right, next test, simulating a power outage, no electricity exception gets thrown. So again, I'm not using an expected attribute here, I'm using an assertThrows. So I've set up my mock here that'll throw an exception when the provide electricity method gets thrown, which I'm doing here. So assertThrows doesn't get a handle on the returned exception. You just want to assert that it gets thrown, okay? So in this case here, I want it to be of this type, and I'm using an executable, like I described before, as a lambda expression to do that. If you want a handle on the exception, then in this case here, where I'm passing a null electricity provider, that won't get us any electricity when we actually call the getElectricity method, we're going to be using expectThrows instead of assertThrows. So assertThrows actually internally calls expectThrows, but it disregards the return value, okay? expectThrows doesn't disregard it. So you get a handle on it, and then after that you can inspect it. So I'm using an assertAll here, which is new to JUnit 5. You can now group together assertions, which is great because over here, here's a little nice optional feature that you can opt for. This is a header for all the grouping of the assertions you're doing, which I really like, okay? So if this assertion doesn't go through as you expect, you'll see this header, and then it'll print out all the values of all the assertions that you have in here, which is really cool, right? Because before, when you were grouping assertions, if one failed, you didn't get the printouts of the values of the other assertions below that. But now, if this assertion fails, you'll also get the value printed out of what this assertion equals, which is really nice. So before it was discouraged to do this, now it's fine because of that. Okay, so you'll notice again that here I'm using some lambdas to do this, which is exclusive to JUnit 5. All right, now again, just kind of want to go through why it's such a good idea to use these expectThrows in this case, in this test, is because before with the expected attribute, you couldn't do one of three things. You couldn't assert exactly where the exception was thrown, like on what line. You couldn't assert exactly what type was getting thrown. It could have been a subtype of the exception that you wanted. Or you couldn't inspect the state of the object after the exception was thrown, which now you can do in this case, example in the assert all, or just a basic assert after that. So it's a much better design, more robust. Okay. One more annotation on this example. We have the @disabled. So you can disable a test and it'll get skipped, it'll get grayed out. And in this case, I'm saying I need more information on some requirement X to complete this test, awaiting feedback from the client. And over here, you see I started doing some stuff and I came up with an assumption, right? So we have a new assertion called assuming that. And if your assumption is false, the test will get skipped as well, right? So I kind of did 2 in 1 here. And so in this case here, I want the country code to equal Canada, okay? So this is a nice way to kind of have some precondition checks inside some of your test methods. So if I run this, take a look here. All right, let me open up here. Here we've got 4 tests passed, 1 test skipped, right? Because of the disabled over here. Now you'll notice again that the display name here in NetBeans, it prints it out there, but it's not doing a good job. NetBeans is not really ready for the display name right now, especially when you're dealing with nested tests. It should print out in a hierarchical fashion. In the next example, you'll see that it won't. So unfortunately, NetBeans is not doing a fantastic job with the display name because it also prepends the name of the class, and it kind of gets ugly fast. But that'll get fixed soon enough. All right. So last but not least, we'll take a look at the stereo test. A stereo needs to get plugged into an electrical outlet, and then that electrical outlet needs some electricity, and off we go. That's what we're testing, right? So how do we extend JUnit 5? We use the @extend_with annotation. So in JUnit 4, we were using the runners, and I talked about that briefly at the beginning. So one of the limitations of runners is you can have 2 runners on the same class. Well, no more limitation in JUnit 5. You can now specify a comma-separated list of extensions, which these 2, by the way, the Makito extension and the timing extension, I ripped off from the JUnit 5 user guide, okay? And you could also opt to have 2 extended with annotations as well. I just picked 1 here with the comma-separated list. So the Makito extension is nice because it'll allow us to do something which was never before allowed in JUnit 4, which is to provide dependency injection at the method level, but in the arguments. Okay, so in the argument list, you can actually pump in there a mock. So this gives rise to parameter resolvers, right? So if you think of parameterizing tests and stuff like that, this is going to be supported natively in JUnit 5. And so this is just a heads up on how to do that. The timing extension is just a simple extension that's going to take count of how long a test method takes to execute, okay? So kind of like a before and after thing, lifecycle thing. So again, here I got my before each. That's going to set up a new stereo for each test. And I'm just asserting here that whenever I create a new stereo, that the default values are false. Okay, so that's fine. Over here, I have @nested. So you can actually come up with nested classes to make your test more concise, especially when they have a specific context within a larger context. Okay, so if you find your method names start getting really long, right? Then you can opt to have smaller classes, inner classes within them. And how you do that is with the @nested now. You don't need some runner to do that or anything like that. So in this one, I'm saying all the tests inside this inner class are plugged into the electrical outlet, okay? And I come up with a mock, and before each of these tests, I plug in the mock into the stereo, okay? I assert that this is true, that it's plugged in, that's fine. I also have another nested class that says, okay, not only are you plugged in, but you are now, the stereo is powered on. So you notice that my method, that my class names or my method names later on for my test don't have to say plugged in and powered on test or something like that. So another indication that you might need some nested classes is if you have a lot of instance variables in your tests and not all of the @tests are using them, okay? So that's another indication. So this is much more concise. Unfortunately, NetBeans is not printing out the display names in a hierarchical fashion, which it should, but give it some time to catch up. So that's why I like to use display name the best, is when I'm going to get those hierarchical printouts to really give me fine-grained context information on what's going on with the test. Okay. You notice I have another before each here, and in my other class on the top, I also had a before each, and in my outermost class, I also have a before each. So how this works is that it's outer in. So the before each from the outmost one executes first, so it creates a stereo, goes inside the inner class, and over here, I set the stereo with an electrical outlet, and then again, in here, I set up my mock to do something and power it on, because all these tests need to have the stereo powered on. All right. So one last thing I'd like to talk about here is the tag. Okay, so now we can tag methods with your own identifiers, and eventually the build tools are going to be able to filter them out for us and execute just those, as categories did in JUnit 4. Now the support is not in there right now, okay, but know that you can do this eventually. So over here now, really the rest of the stuff that I have here are the annotations that we covered over here. So last but not least is play music. I find this one a little funny because I was trying to be cool, and I think I really failed here. I'm basically saying should play music when play requested. Notice I am injecting a mock at the argument level, right? This is amazing. So we couldn't do this before, and that has to do with the extension that I talked to you about here, the Makito extension that I specified in the extended with. So that'll allow us to do this. So this is my own mock, and I'm free to say when the playlist .get first track from album, blow up your video, then return expected song, Thunderstruck. I don't even know if this is true. I mean, like I said, I was trying to be cool here. This could be like blow up your video, or that's not even the name. I don't know, but I definitely don't feel too cool right now. Like I said, I'm making Java videos now, right? So how cool is that? So Aram is just asserting equals. So expected song has to be stereo.play music, supposed to be playing song, expected song. So this is just a basic assert equals over here. The other things that you can inject as parameter resolvers, there's two built into JUnit 5, which is test info and test reporter. Basically, they're there to give you kind of meta information on your test running, the names, the name of your test, the tags, all that kind of stuff. Okay, I just want to showcase those in terms of that they exist, but they're not really useful in terms of writing tests. What's really nice here is this mock that gets injected into your test method. And eventually, like I said, you're going to have the option to inject a whole bunch of stuff to parameterize your test without having to use a runner to do that. It'll just be built in, or at the very least used an extended with that they'll provide for us. Okay, so a lot less need to use those third-party libraries now to get all that good stuff. So that is basically what I wanted to go through on our overview of JUnit 5, right? Milestone version 1. Hope you guys enjoyed that. Don't forget to subscribe, and see you guys soon. Ciao.